Hello guys, welcome back to Numboid. Today we're going to go through some examples of chain rule questions. So this is the best video for you if you just want to do some practice on chain rule. I'll just be going through it, giving you a question, go through it with you, but I would suggest you pause the video while I give you the question, have a go at it, and then come back and we can work through it together. So let's get straight into the first question. So the first question we have here is f of x is equal to 6x squared plus 7x, all in brackets, to the power of 4. So what you do with the chain rule, first off, is to find f of x. We just treat this as a normal thing. We bring this power down, so 4, and then we differentiate the inside with respect to whatever we are differentiating to. So in this case, we're differentiating with respect to x. So we find 2 times 6x, so it gives you 12x, and then 1 times 7, take 1 off, gives you just 7 plus 7. And then you have this your normal insides again. But because we brought one of this 4 down, we need to take 1 off the top to give us 3. So our answer to the first question here of 6x squared plus 7x all to the power of 4 is 4 times 12x plus 7 times 6x squared plus 7x all to the power of 3. Well done if you got that right. Let's move on to our next question. So our next question we have here is gt equals 4t squared minus 3t plus 2 all to the power of minus 2. So this is like the first one. All we have to do, if we go differentiate it, is bring this down to the top, so minus 2. You got to take that one off, so we got to remember we got to take 1 off there. Differentiate this inside with respect to t, so we get 8t minus 3, and there's no t here, so that goes to 0. Put our normal insides back in, 3t plus 2, and then take 1 off the power here to get minus 3. Well done if you got that one. As you can see, once you get the method down, it's really easy to just bang through these. You can do a lot in a time. Well done if you got that one right. Let's move on to our third question. So this is our third question here, which is tan of 4 plus 10u, and we're differentiating with respect to u. Pause and have a go. This is a bit trickier. Okay, I think if you've paused, you've had enough time to have a go at it. So what we do here is, first off, I'm going to change it up a little bit because there's no power. When we differentiate with respect to u, I'm going to do this inside first. So if we differentiate this, just ignore this tan part and differentiate 4 plus 10u with respect to u, we just get 10. So we take that out to the front. Now we have to differentiate this tan part, and the differentiation of tan is sec squared. So we get sec squared, and then the insides, like there is with anything with a power, with the trigonometric function, there we go. The insides just stay the same as well, so that just becomes 10u. So differentiation of this just becomes 10 times sec squared of 4 plus 10u. Well done if you got that one right. Let's move on to a trickier question with exponentials next. So this is our fourth question here. As you can see, it's got an exponential. So we have ft is equal to 5 plus e to the 4t plus t to the 7. So quite a tricky one. Pause and have a go. We're differentiating with respect to t, and come back when you're ready to solve it. Right, so what we do here is we're differentiating with respect to t. As you can see, this 5 doesn't have a t value, so this just goes towards 0. So we can just forget about that and we can focus on this part. So what we do when we're having exponentials here is we take this, we forget that it's e, we take this bit of here and we differentiate that. So 4t plus t to the 7 differentiated gives you 4 plus 7t to the 7t to the 6. And now all you do is you just pop back in your normal exponential value here at the end. So you got e to the 4t plus t to the 7. And that's literally how you do it. It's really simple once you know how the rules work. So yeah, well done if you got that. Let's move on to our last question, which combines trigonometry and exponentials. So our final question here is e to the 1 minus cos of x. So literally what we have to do, like we did last time, is forget about this e and just look at this section up here. So what we have is 1 minus cos x, and you just got to differentiate that with respect to x, and so we do minus cos x because this one hasn't got anything, so it'll go towards 0. So minus cos x differentiates to give you sine x, so you get sine x. And then what you just normally do is you put your exponential back as it was, and that's literally all you do. It's like I said, as soon as you know the method, it's super easy and super simple to get. So well done if you got all them questions right. Make sure you hit like, subscribe if this was informative and interesting, and make sure you comment to see any more maths videos or anything. Thank you guys for watching, and I'll see you in the next video. Goodbye.